Okay, I think I don't want to annoy you with my German accent too much, so I don't use the microphone. Welcome to our presentation, Neural Artistic Style. My colleague, Ole, and me, Franciscos. Just want to mention we got friends, not just colleagues. This project, maybe the name doesn't say anything to you, so let me introduce you. In our project, we use techniques of neural network to separate and recombine the content and the style of two different images and combine these pictures into one resulting picture, which means we transfer the artistic style of one picture into the other one. As the result, we got a picture, a new generated picture, which is kind of modern art, but not generated or based on a human interaction, but on like algorithm and neural network techniques. Yeah. Okay, this is how it works. I think some of you saw already this picture, like in some lectures of neural network techniques. It's just we put in the network two images. One is the base image, and one is like a style image. And the style image should be applied to the base image by the network, and each hidden layer does some filters like filter maps, which are calculated on similarity of internal representation of these images, like on the pixels, and propagate it to the next. And as something like a best practice, we always took the result of layer number 4 and used this picture as a result. So I mean, it reconstructed the content of the picture. We also specified the amount of iterations, which means like how often this process will be proceed. And we observed in our project that if we used like one iteration, it was very close. The resulting picture was very close to the input image. And if we used many iterations, it was very close to the style picture. So we tried to find something like a trade-off to plot some beautiful pictures. Yeah, this is a mathematical expression. I don't want to go too deep. I think some of you saw it already. Basically, what is important here is that the total loss is the weighted sum of the style loss and the content loss. So our project somehow differs to the last one because it was more like from an artistic point of view than yeah. And this is how it looks like. So, I mean, just to explain, we didn't implement the network. We got it already, it was made for us, and we got already also Python scripts, and we applied it to some pictures, and it was more somehow like exploring and playing around with the pictures to get some beautiful plots. Here's an example. It's the first one, the tiger. On the left is the base image. The second one is the style image. It's Van Gogh. I hope that some of you know the picture. And the resulting picture, the output, is on the right. So our idea was not just to take some random pictures out of the internet. We want to take some pictures you already know or something related to the summer school. So we took some pictures by ourselves, or we took it out from the Slack portal. Can you go to the next page? This is the base picture, as we tell you if you don't know that. This is just the base picture, and you some questions about we applying different styles, like you can see above. This is the style picture, and you already saw the base picture, and this is how it looks like after applying the functions to the picture. And yes, now I just want to show you some examples to give you an impression how it looks like. For example, this picture, this was the very first day on the balcony, and applied by this style image, we got this result. This is my favorite because it looks, I think it looks quite cool. We also observed that if you take a very detailed photo, like a close photo of a face or something, it didn't give good output. And I think this picture was perfectly fit. It's suitable to do this function because the output is very beautiful. Yeah, another example. This is the same. This is the base picture, and this is the style picture. And last but not least, this example. Yeah, that was the presentation. I hope I gave you a good impression what is possible, what is not possible with applying neural network function to images. And thanks for listening, and yeah, Slava Ukraini!